Morning everyone, my name's Matthew Yates and I'm from Central Queensland University in Rockhampton, Australia. Today we'll be examining the manuscript titled A Comparison of Active versus Passive Recovery Between Sprinting Bouts During a Repeat Sprint Protocol. Repeat sprintability, or referred to as RSA, is a commonly used training technique to improve fitness and performance in sport. Repeat sprints occur in most sports. For example, in previous research done on a game of basketball, players attempted as many as 105 high-intensity sprints throughout a game. These are from 2 to 6 seconds. Extensive research regarding RSA, specifically to determine what the most efficient recovery method is. And these recovery methods are broken down into active recovery and passive recovery. So active recovery means jogging at approximately 50% of your maximal speed in between these sprint efforts, and then passive recovery refers to walking or standing during that time between your sprint efforts. Extensive research has been done on cycling and running in repeat sprintability. However, it's important to remember that the correct testing is what you're correctly doing for what sport you're trying to assess. Previous research has identified that running repeat sprints have a much higher metabolic cost than stationary cycling sprints, for example. So it's important to make sure you're doing the right skill for the right sport. RSA performed for this test will be used for running. Onto our methods. We had 9 participants, 6 males and 3 females used for the study. All participants signed ethical and CQU University approved consent forms prior to any data collection. All participants were aware that a maximal workload was required of them. So we can see in Table 1 some of the subject demographic data. Average age is 21.8, the stature was 1.7 metres tall, the body mass 72.8 kilos. The body fat 14.8% and the BMI in a healthy range of 24.4. For the methods of the sprint procedure, a randomised crossover design took place over a 2-day period. So participants completed active and passive sprints exercise on alternate days. So for example, participants would do the active recovery on one day and the passive recovery on the next day, or alternately. 20 metres was the total sprint distance, and timing gates were placed at 0, 5, 10, 15 and 20 metre positions. So this can be seen on the picture to the side, which was taken the day of testing. We can see the timing gate set up. You can see the scribers on the side. One person's holding the RPE sign and the gentleman's about to begin his next sprint. To break down the recoveries, active recovery was made up of 10 20 metre sprints with 30 seconds of active recovery between the efforts, and for passive recovery it was the same 10 times 20 metre sprints and 30 seconds of passive recovery between the efforts. The active recovery was jogging at 50% of the maximal speed for the entire 30-second rest period between bouts, and the passive recovery was made up of decelerating from the sprint and then walking back to the start line to prepare for the next bout. All participants had to be stationary before they started each sprint. For the measurement procedure, during all testing the following measurements were recorded. We recorded blood lactate, heart rate, and rate of perceived exertion. For the blood lactate, it was recorded pre-test, then immediately after the sprints, and then a further 5 minutes after the sprints again. Heart rate and RPE was recorded pre-test, and then at the beginning of each sprint, and then at the end of each sprint. So, or for all 10 sprints at the start and end. Heart rate was then continually measured for a further 5 minutes after sprints. The equipment used was a lactate analyzer, a polar heart rate monitor S610, and then for RPE recording we used the 6 to 20 Borg scale. So we can see some of the equipment over to the side here. We've got the blood lactate analyzer and then the disposable Lancets and plastic gloves and all the safety gear. For statistical analysis, an alpha level of P less than 0.05 was established to determine statistical significance. A separate paired t-test was conducted to determine the results between the active recovery and the passive recovery times, the maximum heart rate between active and passive recovery, and then the maximum RPE between active and passive recovery. All statistical analysis was conducted using the Microsoft Excel data analysis toolpack. On to the results. It was evident that passive recovery sprint times were significantly faster than active recovery sprint times. This is evident in the data in Table 2. If we look at the differences down the bottom, we can see that across all participants, bar 1, which was a very, very minor decline, all participants had a higher time when they did the active recovery. The faster time was the passive recovery. Further in the results, we can see that the maximum heart rate was significantly higher for active recovery compared to passive recovery. This is evident in Table 3 in the maximum heart rate comparison. Once again, referring down to the bottom line for the difference in beats per minute, you can see across all participants was quite a significant increase in beats per minute from the active recovery. Finally, results concerning the rate of perceived exertion. It was significantly higher in the active recovery compared to the passive recovery. This is evident in Table 4 in the maximum RPE comparison. Once again, if we refer down to the bottom line, we can see the RPE across all 9 participants was significantly higher during the active recovery phase. In conclusion, the passive recovery produced the faster sprint times. Active recovery expended more energy, in turn for lower performance. This was evident from the maximum heart rate, so participants knew they were working harder, and it was also evident in the maximum RPE results, and the participants perceived that they were working harder as well. These findings supported our research hypothesis that passive recovery will produce faster sprint times, and these findings were also similar to prior research. A very similar study on healthy young basketball players, in a very similar demographic to this study, reported that passive recovery enabled better sprint performance. This was evident in our study as well. Overall, the study was conducted at the CQU Rockhampton campus. We used 9 participants, and we thank them very much for their maximal contribution. All participants were tested on repeat sprints using the active recovery and the passive recovery, and the results showed that passive recovery produced the fastest sprint times. It was also interesting to note that they produced the lower maximum heart rate and the lower maximum rate of perceived exertion. All the researchers are pleased these results matched up with previous literature. I hope fellow colleagues in the overall sports science field obtain vital information from this study regarding repeat sprint ability. This can then be adapted to training scenarios. As previously stated and supported by all the literature, repeat sprint ability is a vital skill, and it's evident in the majority of sports. The high intensity demands that are important for performance, and the recovery methods must be understood before they can be used in a training facility. Training programs can be easily implemented to incorporate passive recovery into repeat sprint exercises. During team sports where RSA is extremely vital, for example, we'll look at AFL, these 2 recovery methods could be used at different training sessions. For example, you could do passive recovery the first week and then active recovery the second week, and then compare these results between your players to see what worked better, and then that can also be compared with this literature and previous literature. Further on AFL, these recovery modes could even be applied to defensive and offensive structured plays. For example, what movement players move off the ball when they're not in the main scene of the play. Applying this knowledge to training will build a platform to increase performance in game-like situations, which is ultimately what all training situations try to achieve. Finally, you'll find the references used for the presentation. Thanks very much for listening.